Welcome to EDU World Space.
So now we'll work on problem 6 from chapter 20. In this problem, we're asked to consider the following table of standard electrode potentials for a series of hypothetical reactions in aqueous solutions. So it shows us a series of reduction half reactions for fictitious compounds represented by A, B, C, and D, and it gives the standard reduction potential for the reactions shown. So we have four different questions that we have to answer here. First is, three questions. Which substance is the strongest oxidizing agent and which is the weakest? So the strongest oxidizing agent will be the species that is most likely to be reduced. An oxidizing agent is reduced. So the species that's most likely to be reduced will be the one with the largest standard reduction potential, which is A+. So A+ is strongest oxidizing agent because it has the highest reduction potential. Now for weakest oxidizing agent will be the one that is least likely to be reduced, which is the one with the lowest reduction potential, which is D3+. And that's because it has the lowest reduction potential. So next we move on to B, where we're asked which substance is the strongest reducing agent, which is the weakest. So now we're looking for a reducing agent which is most likely to be oxidized. Now the most likely compound to be oxidized would be the weakest reducing agent, but not exactly the weakest reducing agent, because the weakest reducing agent was D3+, which is unlikely to be further oxidized. However, D3+ should be stable. So what that means is that the neutral element D has the lowest reduction potential. So it's more likely to lose electrons to be oxidized to D3+. So D solid or neutral is the strongest reducing agent because it's the most likely to be oxidized. Now for the weakest reducing agent, we have the same idea. We can see that the first reaction, A+ plus an electron, produces the neutral A, and that's a reaction that happens favorably, so the reverse should be very unfavorable. So the solid or neutral A will be the weakest reducing agent. Then in part C, they ask us which substance can oxidize C2+. So we're looking for an oxidizing agent. We want a sample to be reduced, and we want to oxidize C2+. We want to remove an electron from C2+. So the reaction for the standard reduction potential for the reduction of C3+ is negative 0.12. So for the oxidation of C2+, it would be 0.12. So we need a value that's higher than that for our oxidizing agent. And the only two values that give a value higher than that are A+ and B2+.